In this video, we're going to perform operations on function, including adding, subtracting, multiplying, dividing, and a new operation called composition of functions. We're also going to be looking at how to figure out the domains of our results. So let's start with the four basic functions. This is easier than it probably looks based on what you see here on the screen. What these notes are giving you is that if I want to add two functions together, I'm going to take the two functions and I'm going to add them together. This means we're going to combine like terms. So remember, like terms means they have the same variable with the same exponent. If they don't have the same variable and the same exponent, then we just write it out all the terms. Subtraction is the same thing. The big thing we need to watch out with subtracting two functions is if the second function has multiple terms, we need to be able to distribute the negative to all the terms in the second function. Multiplying is distributing, so we're going to multiply f of x times g of x. We're going to distribute from one term to the other. Dividing many times is just writing one function divided by another function. The big thing is, and this is where that domain is going to come in really strong, is that we create a restriction to the domain when we put a function in the denominator because that function in the denominator cannot equal 0. So we could create a restriction that wasn't there in the original functions just by putting a function in the denominator. So let's review our function notation while throwing in some of these operations that we're looking at. So here we're going to just kind of remind you of what function notation is and how we work with it. So let's start with number 1, f of negative 3. Well, f of negative 3 means I'm going to refer to the f function, and I'm going to plug negative 3 in for x. So f of negative 3 is going to be negative 3 squared minus 3 times negative 3 plus 1. Notice that I have put negative 3 everywhere there was an x. That's what we mean when we do function notation. When I calculate that, my answer is 19. Go back up here and get my pen. Okay, let's do g of 4. Well, g of 4, I'm using the g function. Here's the g function. And I'm going to plug 4 in for x. So let's go up here and plug 4 in for x. So g of 4 is the square root of 8 minus 4. Okay, which 8 minus 4 is 4, and the square root of 4 is 2. So that would be my answer. So let's look at number 3. I'm back to using the f function. So f of a plus 1 means that I'm going to put a plus 1 everywhere there's an x. So in all those places. So you're going to do a plus 1 squared minus 3 times a plus 1 plus 1. Now this means we're going to actually have to multiply this a plus 1 out. Remember, it's not just a squared plus 1. We actually have to distribute. The result of that is a squared plus 2a plus 1. And then when I distribute that, I get minus 3a minus 3 plus 1. Then when I combine like terms, I get a squared minus a plus 2. Now let's go back to the g function again. The g function, remember, there's where the x is, so 10 goes in there. So the square root of 8 minus 10. Well, the square root of 8 minus 10 is the square root of negative 2. And we know the only way we can write that is I square root of 2. Now let's go and look at this one, because this one is actually asking me to do f minus g. So I'm going to do f minus g. What that means is I'm going to do f of negative 8 minus g of negative 8. Well, what is f of negative 8? Well, f of negative 8 is when I plug negative 8 into the f function. So negative 8 squared minus 3 times negative 8 plus 1. So that is my f function. Then I'm going to subtract what happens when I plug in negative 8 into my g function. So square root of 8 minus negative 8. So what does that equal to? Well, f of negative 8 turns out to be 89. That means you're doing negative 8 squared, and then you're going to multiply negative 3 times negative 8, which is positive 24, plus the 1. So you're going to get 89 out of that. On the other side, the square root of 8 minus a negative 8, that's 16, square root of that is 4. And so then I'm going to subtract those two values and get an answer of 85. So let's do G times H. So we're here. G is the square root of 8 minus x. So we're going to have to do the square root of 8 minus 0 times H. H is over here, so we're going to do 2 over 0 plus 1. So we're going to multiply those two things together. So this is multiplication. Well, what is the square root of 8 minus 0? Well, the square root of 8 minus 0 is the square root of 8. And what is 2 divided by 0 plus 1? Well, 2 divided by 0 plus 1 is just 2. So when I multiply those results together, I'm going to get 2 square root of 8. Now, you can simplify the square root of 8. It's really not the focus right now, but remember, just kind of as a gentle reminder, we can break this down into 4 times 2, and then 4 broken down into 2 times 2. So I have a pair of 2's. So the square root of 8 will actually simplify into 2 square root of 2. But then I need to multiply by 2. So my actual answer is 4 square root of 2. Just in case you have to simplify that all the way down. And then lastly, I have h of negative 1. Well, that means I'm going to do 2 over negative 1 plus 1, which gives me 2 over 0, and that is an issue. So that particular thing is not defined. It does not exist, or you can say that it's undefined would be your answer. So let's do some more evaluating, but this time we're going to talk about what's the domain of the result. Okay, so we're going to start with r minus t of x, which means that we're going to do, let me change that color. We're going to do r of x minus t of x. So what is r of x? Well, r of x is x squared plus 3. That's r of x. We're going to subtract t of x, which is x plus 4. Now remember, when we are subtracting, we have to distribute that negative. So what we get is x squared plus 3 minus x minus 4. So the result of this, when I combine like terms, is x squared minus x minus 1. Now, let's talk about what's the domain of that. Well, if you look, the domain of x squared plus 3, that's a parabola, and we know the domain of a parabola is all real numbers. T of x is x plus 4. The domain of that is all real numbers because it's a line. So when we subtract, we actually don't change anything. We don't create a restriction that's not already there. So therefore, the domain of this result is actually still all real numbers because we haven't created any kind of restriction. So let's look at another one. Let's look at number 9, r divided by t of x. That means we're going to do r of x divided by t of x equals, what is r of x? Well, r of x is x squared plus 3. What is t of x? X plus 4. So there's my quotient. But what is my domain? Well, the thing is that both of these functions have domains that are all real numbers. But when I put that t in the denominator, t plus 4 can no longer be 0. So now I have a restriction that t can no longer be negative 4 because it's in the denominator of a fraction. X plus 4 is now in the denominator. So I have to write my interval notation excluding negative 4. So that's going to be negative infinity to negative 4, unioned with negative 4 to infinity, because we have to exclude the value of negative 4. So let's look at the next one, s times t of x. So this is going to be s of x times t of x. So s of x is going to be 2 over x times t of x, which is x plus 4. So best I can do there is to do 2x plus 8, distribute that 2 over the x plus 4 over x. Okay, now we got to think about what's the domain of s of x. What the domain of that, since x is the only thing in the denominator, is x cannot be 0. That doesn't change when I multiply by x plus 4 because x, all that's in the denominator is still just x. So x can't be 0. So what does that look like in interval notation? Well, we stop our interval at 0. So we're going to negative infinity to 0, union with 0 to infinity, and use those parentheses to indicate that we're not going to include that value.